Okay, so I talked to you earlier about the EVT, the extreme value theorem, right here. And again, this is just an existence theorem. This is the EVT, and it is an existence theorem. Okay, basically it just states this is happening. So the EVT states right here that if you have a function that is continuous and finite, meaning it has a specific beginning and a specific end, right here, okay, then f will have both an absolute max and an absolute min. Okay? So this is just a statement. Boom, done. It doesn't tell you anything else. Here, this theorem, if f has an absolute extremum, meaning an absolute max and an absolute min on the open interval, then it must occur at the critical point of f. Okay, so remember, what we're looking for is the critical points or critical numbers. This is where f prime is equal to 0 and where f prime is undefined or does not exist. Okay, and this is actually going to occur when we have a rational function. If we have a polynomial, this doesn't happen, right? Because the domain is negative infinity to positive infinity. And one thing you need to make sure you understand is that we can determine f prime at a vertical tangent line, but not at a vertical asymptote. Okay, and we can do this because at a vertical tangent line, that x value is not undefined everywhere, but in a vertical asymptote, it is undefined everywhere. Okay, so the critical point cannot occur at a vertical asymptote. You just need to make sure you know that. Okay, so this is the procedure, and we're going to go through it for this first problem, but I just want to make sure that everybody understands you are using a finite closed interval, okay, and we're looking for absolute extrema. Okay, so the first thing that we want to do is find the critical points of f in the open interval. Okay, so again, just like I said, you're going to take f prime and set it equal to 0. And then if you have a denominator, if it's a rational function, I'll move up, okay, you would take f prime in the denominator and set it equal to 0. Again, this is if you have a rational function. Okay, then what we want to do is evaluate f at all critical points and the endpoints, a and b. So this is what's different. In the relative, we would put those critical numbers from the derivative on a number line and test them in the derivative. We are now testing these critical numbers, critical points, in the original function because we want to know the absolute extrema for the function itself, okay, not for the derivative. So then the largest value, meaning y value, okay, the largest value that you find is the absolute max, and the smallest value is the absolute min. And remember, we are looking for the y value. Okay, so here's the deal. When we're doing this right here, we're going to use what's called a truth table. Truth table. No serum. Okay, so here's the deal. First of all, there are some of you who like to do your work in the form of sprinkles or a sprinkler or whatever, meaning you got work here, you got work there, you got work everywhere. In a truth table, everything is organized. So I'm expecting to see that in your homework, on your quiz, on your test, and when you sit down to take the FRQs for the AP exam, provided you do that, you get points for doing the truth table. So they want to see it. Okay? So I'm expecting to see it. So here we've got our question. It says find the absolute max and absolute min values of this given function on the closed interval from -3 to 2, and then state where those values occur. So obviously we're going to have to make a statement in the sentence form. Remember before we were using by the first derivative, by the second derivative. I know some of you get annoyed by that, but this is an AP course and we are expecting you to write. Yes, you have to write in math. I know it's terrible. So the first thing that we want to do based on our steps is we want to take the derivative of our function. So f prime of x is equal to 6x squared plus 6x minus 12. Okay, you guys told me to find critical points. We would then set our derivative equal to 0. Can I take out a 6 too? Okay, you want to make it as simple as possible. So 6 times x squared plus x minus 2 is equal to 0. Okay, now what? How do I find the critical points? What do I need to do? Yes, absolutely, factor. 6 times, what are my factors? Yep, x plus 2, x minus 1 equals 0. So here we have critical numbers where x is equal to what? Negative 2 and 1, not 0? Okay. Some of you made this mistake a long time ago. I'm sure you will not make it again. Remember, 6 does not equal 0. It's just a common factor. There's no variable. If there was an x there, it'd be different, right? Okay. So these, I need to make sure on my interval. Do negative 2 and 1 fall in the interval? Yeah. Okay, good. They are in the interval. Check. So this is what we want to do. We are going to create our truth table. And in the truth table, you're going to state your candidates. What that means is your critical numbers and your endpoints. Those are your candidates. Those are the ones that you're going to be testing in f of x. So we're going to make our table like this. Okay, and let's put these in order from smallest. So this is my x value. We've got negative 3, negative 2, 1, and 2. Okay, why like that? Because that's how they like to see it, so we're going to practice it like that. Okay, in order. Then we are actually going to test them in f of x. So this is where it can get kind of cumbersome because you actually have to plug in. So we're using the original function, f of x. Okay, we are not using f prime. We're using f of x. It's right here. All right, so this is what we're going to do. We're going to evaluate f of negative 3, and we're going to plug in. So this is 2 times negative 3 cubed plus 3 times negative 3 squared. It's going to be long. Is it minus 12 times negative 3? Okay, so it's minus 12. Yep. So this is negative 27 times 2. What is that, negative 54? Positive 9, so plus 27, and then plus 36. Okay, negative 54 plus 27 is negative 27 plus 36. What is that? 9. Okay, there's one answer. I don't know what it is. I don't know if it's a max or a min. It's just an answer for a candidate. Everybody good? Okay, these are all non-calculator questions, so we've got to be careful with our math. F of negative 2. Here we go. So this is, and I'm just looking at the function, so it's 2 times negative 2 cubed plus 3 times negative 2 squared minus 12 times negative 2. Did I plug in correctly? So this is negative 8, negative 16, plus 12, plus 24. Is that right? So this is negative 4. Is that 20? Okay. Okay, that's circled. Let's plug in 1, f of 1. So this is 2 times 1 cubed plus 3 times 1 squared. Oh, these are awesome. Minus 12 times 1. Ones are good. 2 plus 3 is 5. What is that? Negative 7? Okay. And then the last one, f of 2. 2 times 2 cubed plus 3 times 2 squared minus 12 times 2. 16 plus 12 minus 24. So this is 4. Okay. So a little bit annoying, but I mean, it's not that bad. It could be worse. This is probably the worst part. Okay, so now what I need to look at is what is my highest y value and what is my lowest. So what is my highest y value? Okay, so this is an absolute max. And my lowest? Yep, absolute min. Okay, this is not how you're going to give your answer, but I'm just writing it so that we see it. Everybody good so far? What we've done, how we found them? Yes, ma'am.
Is there a reason we didn't do 0?
Why would we have done 0? It wasn't a critical number.
But
-3 was a critical number because it was on the interval. So these are your endpoints, and then these are the critical points. Are you with me? Okay, that's fine. Legit question. All right, last step. In step number 3, which you do not have to number these steps, but it just basically goes from the top. That's where the 1, 2, 3 is coming from. Okay, if you're doing this in a writing prompt or whatever, you can number the steps. It's your call, but you don't have to. The last part is on the interval. Okay, and we're talking about the interval that they gave us from -3 to 2. F of x has an absolute max. See, abbreviated. Where? At no.
Y equals 20.
You could say at 20.
F of -2.
Or you could say f of -2 is equal to 20, or you could say 20, okay? But don't give just the x value, okay? You could give it as -2 comma 20. You got to have that y value in there. And then you would say, and an absolute min at f of 1 is equal to -7, whatever. It's got to be the y value. You're better off giving it something like this because you already had it here. Okay, but this is pretty much everything that you need to give. Does anyone have any questions? Yes?
So since this was on a closed interval, we use -3 and 2, but if it was open on parentheses, we wouldn't use those.
Okay, so in the EVT, it says that you have to have a closed interval. If it's on an open interval, then it's probably going to be a relative min or a relative max. Okay?